Thank you for watching my presentation. I'm Kenta Yamamoto from Kyoto University. I introduce our study about a character expression model affecting spoken dialogue behaviors. People feel impressions of opponents' characters in dialogue. So character expression is important for spoken dialogue systems. These systems have been applied to many social roles. For example, museum guide, counselor, and attentive listener. It is important to have characters suitable for such social roles. For example, guide is extrovert, counselor is emotional stable, attentive listener is polite. Related studies investigated the effect of characters. In these results, a character expression affects dialogue task achievement and trust in systems. So, character expression is needed for human-level dialogue. In addition, some studies propose the method of character expression. These studies focused on a text content. However, there are many features in spoken dialogue other than a text content. So we focused on spoken dialogue behaviors for character expression. My presentation will follow this outline. In the first two chapters, I explain how to build a character expression model. In the second two chapters, I explain two types of evaluation of the model. First, I will explain a definition of characters and dialogue behaviors. In our study, a character is defined as a combination of three traits. These three traits are extroversion, emotional instability, and politeness. Extroversion and emotional instability are based on Big Five scales in psychology. And politeness is important for the particular use case. Any character is determined by the 7-point scales of these three traits. We use 4 spoken dialogue behaviors for a character expression. First behavior is utterance amount. This behavior is the ratio between length of a system's utterances and the user's utterances. Second, backchannel is the number of backchannels. Third, filler is the number of fillers in system's utterances. Last behavior is switching pause. This behavior is average time length between the end of opponent's utterances and the start of system's utterance. These behaviors are related to the impression of speakers in previous studies. This is an overview of our study. We set the character in a spoken dialogue system. The system controls its dialogue behaviors. A user recognizes the character of the system through 4 behaviors. Next topic, I explain about character expression model. We propose a character expression model controlling 4 dialogue behaviors according to the given characters. We trained 4 logistic regressions for each dialogue behavior. Inputs of the model are 3 character traits in the range from 1 to 7. Outputs are control amounts of 4 dialogue behaviors in the range from 0 to 1. I explain how to collect training data. We prepared 20 audio samples of dialogue between a robot and a human in Japanese. In each sample, we control robot behaviors. For example, a robot uses a lot of back channels. 46 subjects listened to the samples and evaluated character impressions via questionnaire. In these results, for example, when the robot has long utterances and many back channels, few fillers, and short switching pause, subjects feel extroverts. We use this data to train logistic regressions. We evaluated that the proposed model expressed characters in subject experiment. We prepared 16 dialogue samples between a robot and a human. A robot was given a different character in each sample. We controlled robots' behaviors by the proposed model. 11 subjects listened to these dialogue samples and evaluated character impression. In the results, we calculated Pearson correlation between characters of the robot and subject's evaluation of characters. It is shown that significant trends were observed on extroversion and politeness. Third topic is corpus-based analysis. This analysis is an evaluation of the proposed model. In the previous experiment, the model was trained using artificial dialogue data, so we investigated generality of the proposed model using natural dialogue. In this analysis, we estimated speakers' characters from their dialogue behaviors. We can observe many natural dialogue behaviors in a corpus, so we evaluated the validity of the estimated characters using a corpus. We used human-robot dialogue corpus. Each dialogue length is about 10 minutes. 4 operators talk with subject via a speaker of a robot. In this corpus, they talk on 3 different dialogue tasks: speed dating, job interview, attentive listening. The purpose of the dialogue depends on the task. Our hypothesis was operators use different characters among these tasks. We created a dataset for the analysis. First, we divided each dialogue into 2-minute segments. We analyzed dialogue behaviors of the operators in each segment. Finally, we estimated characters from these behaviors by the proposed model. Each dialogue behavior is normalized from 0 to 1. Utterance amount is classified into 0 or 1 based on the median. Backchannel is the number of backchannels divided the number of subjects IPU. Filler is the number of fillers divided the number of operators IPU. Switching pause is linearly converted to the range of from 0 to 1. We calculated the operator's character from these dialogue behaviors by the proposed model. We explained the results of distributions of estimated characters for each task. In speed dating, operators are extrovert, emotionally stable, and polite. We think this is because the purpose of speed dating is to build a relationship during the first meeting. In job interview, operators are introvert, emotionally stable, and polite. Job interview is formal dialogue, so operators are calm in dialogue. In attentive listening, operators are extrovert and polite. In this task, operators have to express the feeling of listening to subject's story. So operators use a lot of back channel and so on. Thus, the character distribution captures the purpose of each task. This is the result of distribution of estimated characters for each operator. We explained the results of the speed dating focused on extroversion and politeness. It's shown two trends among operators. Operator A and B are extrovert and polite. Operator C and D are neutral. According to results of analysis, the proposed model expresses characters that are suited different tasks and operators in the corpus. Next, I explain about a subjective experiment. In this experiment, subject evaluated the estimated characters in previous corpus analysis. We prepared 15 dialogue from the corpus as video samples. For each sample, we estimated the operator's character by the proposal model. 13 subjects watched to each dialogue video and evaluated the impression of characters. For example, subject answered agree, not agree, or neither to question, is this robot extrovert and little casual? This is example of video using the experiment.
そうなんですね。
喜んでいただけたんです。で、私はその横に苗がもう本当に古い苗に戸を開けてみたら、
はい。あ、苗が、はい。
5つぐらいその葉っぱの袋が入れてあんやけど、その袋が雨でズクズクなって、もう処理のしようのないぐらい古いもの。大変な。はい、ゴミやったんです。で、それを、
After subject watched the video, they answered agree or not agree with the description of characters. In the results, the ratio of agree in subject answers in 60%. This is significant trend in binomial test. So, the estimated characters using proposed model are acceptable by subjects. Conclusion. We proposed character expression model in spoken dialogue systems. The model expresses 3 character traits using 4 dialogue behaviors. We investigated the naturalness of characters expressed by the model using the dialogue corpus. In this result, the model expressed the reasonable differences of characters among dialogue tasks. Finally, we evaluated the proposed model in the subjective experiment. In this result, estimated characters by the proposed model were accepted by subjects. In future work, we will conduct live dialogue experiment using a robot. Thank you for listening.